So now let's look at area of a sector. It's going to work very similarly to arc length, where we've got part over whole. We can set up some ratios here, set them up in a proportion, all right? But the area of a sector, remember, is part of the total area. So how do I find the area? Pi r squared. All right, so the area of a sector over pi r squared equals the measure of the arc over 360 degrees. So remember, the area of the sector is we're filling that part in now. We're filling that kind of pizza slice. We're filling that in. So the area of the sector, after we cross multiply, will equal the ratio with the degrees times pi r squared. All right, so find the areas of the sectors formed by angle RQS. So the first thing I'm going to find is this sector right here. I'm going to find the area of that sector. We know the radius is 5. We know that central angle is 63, making RS, the measure of that arc, 63. All right, so we know 63 out of 360 is going to equal the area of the sector out of pi r squared. And my radius is 5, so this is going to be pi 5 squared. So now if I simplify some things, we can keep this as 63 out of 360 equals x over 25 pi. So bring out my calculator. So then we got 63 times 25 pi divided by 360, and I'll get x equals 13.744, and then we don't have any units here, so I'm just going to say units squared. So there's the first one. All right, but what if we wanted, because we want to solve for the area of both sectors that are formed here, which means I want to find the area of this filled in green as well. Well, we could set up an entirely new proportion. If I took 360 minus 63, the measure of this major arc is 297. So we could set that up. But remember, the area of the sector is part of the total area. All right, and this total area is being broken up into two sectors, the red part and the green part. Well, we know the red part, so what if, to find the other part, we just said, okay, 25 pi, this is the total area, and what if we subtracted 13.744? Okay, so I'm going to take 25 pi, and I'm going to use the memory capability in my calculator. I'm going to subtract, and instead of just rounding this, I'm going to go up so I'm using the full exact answer, the non-approximated answer. All right, yes, it's messy decimals, but we're going to get that it is 64.795 units squared. So that would be the that would be the area of the bigger sector with the major arc. All right, so we could set up another proportion, or we could just use that whole idea of part plus part equals whole. Okay, let's do one more problem. Find the arc length of AB. Find the arc length of AB. We'll notice what's given to us. Notice what's given us. We are given the 45 degrees. All right, which means that the measure of this arc is going to be 45. But we're also given the area of that sector as 22 meters squared. All right, so arc length, remember, arc length is part of 2 pi r. But notice, we don't know what the radius is here. This is two variables. We don't know how to solve this right now because we have two variables, x and radius, the arc length and the radius. But what could we do here? We've got, what do we know? we've got 45 out of 360. We also know the area of the sector is 22. And 22 is part of pi r squared. Oh, so here, when I set up this proportion, I've got my, the only variable I've got is my radius. All right, so maybe we could solve this. We've got, if I cross multiply, I got 45 pi r squared equals 360 times 22, 7,920. So from this step, I'm going to divide both sides by 45 pi. We got to be careful here because r squared equals 7,920 divided by 45 pi. So when I plug this into my calculator, I need to divide this by 45 pi, which means I need to put it in parentheses so that my calculator divides it by all of 45 pi. If I forget my parentheses, it's going to divide it by 45 and then multiply that by pi. Notice how those are not the same answers. We do not want this one. We want to divide it all by 45 pi. So we get r squared equals that whole mess. So to get that by itself, I just need to take the square root of both sides. So I'm going to take the square root. Oh, nope. Ah. Oh, did it really go away? That's okay. We can plug it in again. (7,920) divided by 45 pi. And then I need to take the square root of that answer, and I'll get that the radius is 7.485. Okay? So now that we've got the radius, now we can set up another proportion in order to solve for the arc length. All right, we've got 45 out of 360 equals, now we've got the arc length out of 2 pi r, which is this 7.485 mess. All right, so I'm going to multiply this by 2 pi. I'm going to multiply that by 45, divide that by 360, and I'll get that the arc length is 5.879 meters. All right, so that's a little complicated one because you can't just automatically set up that arc length ratio. You can't set up that proportion. Instead, you got to work backwards first, find your radius, and then use that radius to set up another proportion so you can solve for arc length. Okay, so I've got 3 you try now problems for you here. All right, there's one last thing I want to say, but I need to find like an open space that I can write it. Not a whole lot of open space. I'm going to kind of just zoom in here. So the whole concept here is that you can set up these ratios as part over whole. You could do the measure of the arc, and that is part of 360. You could do the arc length, which is part of your circumference, which is 2 pi r. Or you could do area of a sector, which is part of the total area, pi r squared. All right, so each of these ratios are equal to each other. So you can kind of swap them in and out depending on what you're given. All right, so you kind of saw that in number 2 here. We needed to find arc length, but we weren't ready to use the arc length ratio. So instead, we used the area of a sector ratio in the measure of the arc to work backwards to find our radius. That way, we could then set up the proportion we needed to solve for the missing variable, which was the arc length. Okay? So just make sure you understand these ratios. You can set them up in a proportion. Cross multiply. Be careful with your calculator and all that stuff. But I've got 3 you try now problems for you there. They're great practice problems. Let me know if you have any questions. We'll go over those next time I see you. Have a good one.